So we need to find the values of x for which the given geometric series converges, and we also need to find the sum of the series. Well, now to find the value of x for which the series converges, we will apply ratio test by finding the limit L, which equals the limit of the absolute value of a n plus 1 over a n, where n approaches infinity. This equals the limit of absolute value, of absolute value of negative 1 over 2 to the power of n plus 1 times x minus 5 to the power of n plus 1 over negative 1 over 2 to the power of n times x minus 5 to the power of n, and n approaches infinity. This equals the limit where n approaches infinity of negative 1 over 2 times x minus 5. And we need the absolute value of this. So this equals the absolute value of 5 minus x over 2. We know that the series converges if L is less than 1. So if 5 minus x over 2 has to be less than 1. That means that negative 1 is less than 5 minus x over 2, which is less than 1. Then let's multiply all sides by 2. So we get that negative 2 is less than 5 minus x, and 5 minus x is less than 2. Now we will subtract 5 from all sides. We get negative 7 is less than negative x, and negative x is less than negative 3. And now we get that x is greater than 3 but less than 7. So this is the convergence interval. Now we will need to check the convergence at endpoints. So at x equals 7, we get that the series becomes the sum from n equals 0 to infinity of negative 1 over 2 to the power of n times 7 minus 5 to the power of n. Then this equals the sum from n equals 0 to infinity of negative 1 over 2 to the power of n times 2 to the power of n. So it equals the sum of from n equals 0 to infinity of negative 1 to the power of n. So it approaches infinity, which is divergent, so divergent at this point. And let's check x equals 3. In this point our series becomes from n equals 0 to infinity negative 1 over 2 to the power of n times 3 minus 5 to the power of n. It equals the sum from n equals 0 to infinity of negative 1 over 2 to the power of n times negative 2 to the power of n. As you can see, this also approaches infinity, so this is also divergent. So that means that the required values for x for which the series converges is x is greater than 3 but less than 7. Well, now since so we have found the convergence interval. Now since the series is a geometric series with a equals 1, r equals negative 1 over 2 times x minus 5, which is 5 minus x over 2, we can use the sum of the infinite series for geometric series to find the sum. Then s equals a over 1 minus r, so it equals 1 over 5 minus x over 2, so it equals 2 over 5 minus x. So the required sum